All right, good afternoon, Warriors. Good to see you. Hope y'all are doing well. Hump day, midway through the week. And on the screen, we've got our map check for today. We're going to talk about total quality management, which I think is really a fun topic. And most importantly, more than being fun, there's tools in there that I'm convinced you can use today. All right, that's the cool thing about it. You can instantly put this stuff into motion, whether it's in your own lives or in other courses or an internship or some job you got or whatever. Anyway, that's what we're going to do today. On Monday, we're not going to have a Zoom. We're going to have a quiz like we've had in the past. It'll be a little bit longer. I haven't exactly figured out, but I'm going to have it at least available for the amount of time that I've had it available. It'll just be on a Monday as opposed to Wednesday, and it will cover both what we covered today and what we covered on Monday. So lean and total quality management. And then this time next week, we'll do our final exam prep. I'll solicit you for any kind of things you want me to cover during that session. We'll do some Kahoot. We'll do it all. We'll talk about what's going to be on the exam and what you should expect. And we'll get it all out. And then next Friday, not this Friday, but the 8th, I'll post your final interaction and participation assessments. And on that day, we'll also do reading day repetitions. I'm going to talk some more about that in a second. And then 2 weeks from today, holy cow, we'll have our final exam. All right. So let's talk about reading day. Reading day reps are not mandatory. Okay. I say again, these are not mandatory. What you do on reading day is up to you. You play golf, you could chase your brother around, you could study all day, you could do all the above, you could do none of those things. One thing you could do if you want to is schedule time with me, one-on-one time for some last minute review. If you don't want to do that, that's cool too. There's no black book here. I don't give extra credit for folks signing up for time. If no one signs up for time, that just gives me a chance to do something else, okay? But if you want a slot, contact me as soon as possible, identify what slot you want, and we'll go from there, okay? So that's what reading day repetitions are all about. Here's what we're going to do today. We're going to go into TQM. I am going to get some solicitation, some engagement from you today. So we'll have some fun. We have some fun scheduled along the way, so don't snooze out on me. I will call on you from time to time for some input. But before we begin, particularly on this, are there any questions out there on anything, big or small? No questions. Okay, super, I guess. Hopefully that means everything is very clear and straightforward, or not. I don't know. All right, so here we go. Total quality management. Let's get it bigger. It's got to be bigger. All right, total quality management. We'll go into the purpose, the costs of quality, and the tools of quality. We'll spend most of the time on the tools because that's the stuff that I think you can use the most instantly. And so therefore it'll probably resonate with you most. And I'll go into examples of each one as far as I can, being cognizant of how much time we have. Okay. So that's our simple agenda for today. But before I go into that, just a little bit of shameless plug. And so there might be something in today that you like. And just keep in mind that we teach a whole course on total quality management. As a matter of fact, in the fall, I'm teaching this course. So just a shameless plug, we teach more courses on this kind of stuff. If there's anything that you do like, whether it's TQM, Lean, we have a course on Six Sigma. Lean and Six Sigma, I don't personally teach, but my colleagues do. And they're great courses. We also have courses on operations management, logistics management. We have a beautiful thing called data-driven decision-making. And the bottom line is, if you enjoy and you've enjoyed this stuff, big or small, why get one piece of the action get some more pieces of the action, come ride with us in the Warrior Nation. We have majors, we have minors. It's never too late. We've had people switch majors at the beginning of their junior year. So if you're like, man, I really dig this stuff, it's going to be sad to see it go, you don't have to see it go. You can continue to get some more piece of the action. If you have any questions about how to do this, you know how to get hold of me. But if you're like, man, I can't wait to get out of this class, well, that's cool too. I love you either way. All right, so shameless plug is over. Let's talk about total quality management. The purpose of total quality management is very simple and almost potentially understated, which is to improve quality at every level. Now, you might think, well, who wouldn't want to do this? Well, that's a very good question. I would think that every business would want to do this. In my experience, people throw the term quality around very loosely. I'll give you a quick example. One of my prior jobs, I was on a committee. We would meet every month, and we would have people in various departments from, it was kind of an installation kind of committee, and various agencies throughout the installation would say, yeah, we had an event and it was really quality. And inevitably we would ask, okay, what do you mean? Why do you say it was quality? And you would get these really nebulous definitions of quality. Like, well, we had a lot of people show up, so it was quality. And so my point is that I think a lot of people throw around the term quality, but TQM is a lot more specific than that. TQM is an umbrella approach to a lot of different sub-approaches, but they all get after the same thing, which is these three words right here under this bullet. How do we define quality specifically? How do we measure quality? And how do we ensure quality in our processes? Without those three words, you're just kind of throwing quality around, okay? And again, people do this all the time. And if you really want to disrupt somebody's flow and they go, yeah, we're top quality, ask them one of those three questions. How do you define that? How do you define top quality? How do you measure top quality? And how do you ensure that you have top quality consistently? If they don't know what they're talking about, they'll quickly crumble, okay? If they do know what they're talking about, then they'll be able to provide you examples of that. And then as you continue as a professional, you might ask yourself those three questions. How do I define, measure, and ensure quality in what I do? There's a lot of jobs out there in the workforce that want people to understand TQM. So very much like lean, it is a marketable skill, and there's certifications in it. There's a little bit of a business all behind TQM in itself, and I won't get into that. The second thing we want to keep in mind, why is TQM associated with value chain? What's the connection there? Well, in value chain, I think more, I don't want to say more in terms of good or bad comparing to marketing and other disciplines. It's not about good or bad. It's just comparative. We have flows in value chains. We have things moving. And anytime we have things moving, we have a process behind movement. Okay, we talked about three flows of value chain. We talked about product moving, we talked about money moving, and we talked about information moving. And we also have services that move. Okay, so it's almost a force thing. So anytime we have things moving, we have a process behind that, and we have opportunity to build quality into the process. We have, as long as we have a process, we can define in the process how that contributes to quality. We can ensure quality in the process, and we can measure it. So it really goes well hand in hand. That's what I believe and interpret the connection between TQM and value chain. Okay. But I suppose if you understand TQM, you could extend TQM to any discipline out there: marketing, accounting, entrepreneurship, just about anything as long as you understand what TQM is about. And I think the tools today will give you opportunities to do that. Before we talk about tools, let's talk about costs really quick. So I have these color coded and there's a lot of words here. What I want you to focus on is kind of internal and maybe internal and external. I think the blue costs are kind of, I don't know, let's just talk about the blue. So we have prevention and appraisal. Let's talk about those two kind of at once. So when we have prevention costs towards TQM, we do things like develop quality plans that'll assure quality. So maybe we have a company and we take time to do, well, I've seen a lot of companies do this. We do a strategic planning conference where they usually go outside the company. We call it an offsite. So we might go to a hotel somewhere and get kind of out of the day-to-day and say, hey, how do we ensure quality in everything we do? We might look at some past performance. We might talk about some things. We might make a plan. And so there's a cost to that in implementing the plan. That is what I call a proactive measure. So what we're doing there is trying to prevent a lapse of quality before it happens. Okay, so we're trying to prevent bad things from happening. All right. Appraisal is kind of the opposite, where maybe we've done some production, maybe we've invested in things, and then we inspect it or test it to see if the quality is there. And just the act of testing it and inspecting it, regardless of whether we find errors or not, costs money. Okay. When you think about the word appraisal, where it might further resonate with you is if you've ever been involved, maybe your family or you personally has been involved in the selling or buying of a house. Well, there's the selling price, but then there's also what the house appraises for. All right. So you actually have to pay to get a house appraised. So there's a cost there. Now, the house might appraise for more than what it's being sold for. It might appraise for less. That part is really disconnected. It's the act of getting the appraisal itself. So it's the act of getting the inspection that's going to cost money. Your corrugating, again, has a quality control lab. They pull samples. It costs money just to do that. Okay. Now, related to that I could see being confused with appraisal is that next row down, which is internal failure. Okay. So the difference here, I believe, is, let's go back to, I said your corrugating, I meant your container. Your container's got a quality control lab. It costs money just to operate that lab, to keep the employees trained, to have the software, to all the systems they use to pull samples. That costs money, regardless of the results. That kind of stuff is appraisal costs. Now, suppose that the lab pulls samples and finds that the production process is off. The boxes are too thin, they're breaking, they're not the tensile strength that they're supposed to be for the customer. That is an internal failure. Okay, and that's that third row down. All right, so that's the difference between appraisal and internal. Internal is just the cost of doing the inspection, or excuse me, appraisal is the cost of doing the inspection. Internal is when we find results that we don't want and we got to do something about. Okay. So we have scrap, we have rework. Rework is a big cost. If a company has a lot of rework to do, that adds up very, very quickly. Okay. Now, the final one is external failure, and that's where we don't catch it. All right. So let's say, again, with your container, they're producing boxes and some boxes get out the door and Mars, the candy company, is one of their customers. And they get, let's say they send 2,000 boxes to Mars. Mars starts stuffing these boxes full of candy to put out in Rudders. And as they're stuffing these boxes, like they're breaking left and right. And they're like, what the heck? And they call up your container and they're like, these boxes are not holding up to the standards that we told you to. Now your container has to pay to replace the boxes. They have to pay, to recall the boxes. They got to figure out what to do with the material. And potentially Mars might say, to heck with you. We're tired of this. We don't have time for this. We're just going to go to another manufacturer to make our boxes. That obviously would be the worst case scenario. But all of that external failure, meaning once it's kind of left the business and it goes further downstream, if we have failure there or an absence of quality, we have costs that are associated with that. Okay, so from top to bottom, the blue are kind of, prevention and a little bit of reaction, although appraisal isn't really a reaction. It's just the act of inspecting itself. But then the tan ones, I think it's easier to think about. Do we catch it before it leaves or do we catch it after it leaves? And I don't think it's a matter of which is better. I suppose that if we catch it before it leaves, probably costs will be less. But that's not a hard and fast rule either. This is just a framework of kind of setting the stage of why is all this effort on quality worth it? And because if we don't have an eye on quality, then it can be costly. And this is kind of a framework of where and how it can be costly. Okay. So now that we kind of have an idea on the potential costs that we could incur if we take an eye off of quality, the next thing that falls out where we'll spend the most of our time today is what tools do we have to ensure, define, ensure, and measure quality. Okay, so that transitions us to this. And I got a picture of the Punisher on the left because admittedly, I kind of like the Punisher, but I always like to think of tools of, whatever it is you do, whether you like working out or you're like working out outside or you like doing gardening or whatever, you got to think about what's the right tool for the right job. And not every tool is created equally. I'm not going to use a circular saw to clean the side of my house, and I'm not going to use a pressure washer to cut boards. All right. So I got to know what the tool is for and what it does. And not all tools are created equally. That's the main thing. So we have 7 tools here. I think we actually have more. Some of them I like more than others. You'll hear a little bit of my bias come out. But again, the bottom line, that define, measure, and ensure, I think you can't go wrong with that. What are these things for anyway? All right, so the first one is quite simply a flow chart. And the flow chart tells us, really it comes down to, in my mind, how we're supposed to use our resources properly. So for example, this is a process. We have flow here, and where do we want to put like machines? Where do we want to put inventory? Where do we want to put our best people? Maybe we have some people on, we have a few amount of people early in the process. Maybe we have a lot of people later in the process. Not all of these steps are created equally. Some of these, if we don't do them correctly, can, like a house of cards, just bring our process down to the ground in an instant. And so that's what the second bullet means, is it potentially integrates quality into the process. And when I say potentially, I mean, you got to know what you're looking for. So, this particular example has a lot of inspection built into the process. Sometimes that's unnecessary. There's no hard and fast rule there, but it may be necessary that you need to pass inspection on each one of these steps because each one of these steps is equally important. Okay. So I'll just go into, a quick example of a flow chart. All right. So, we take a customer order right here. And let's say we have two types of customer orders. We have one type that goes here. We have another type that goes here. We know here there's two stations involved. Okay. A and B. And here we have three stations involved. Okay. And with each one of these stations, maybe we have a little bit of raw materials along the way. So that tells us where these raw materials are necessary. Maybe we have this situated, if it's a kind of a cellular layout, we have people that can go back and forth. So they could work over here and they could also work here. But then, maybe we just know historically that if we're going to have problems, we're going to have problems here. Maybe this is some kind of calibration activity that we're putting together something with complex components. So, maybe we will do some kind of calibration test right here. And that calibration test, the purpose of that is to ensure that quality of the device. Because without being maybe it's a scale that we stand on every morning when we weigh ourselves. And so a scale is only as good as, its accuracy. So we don't want to be selling scales that are inaccurate. So we build in a station here to ensure that that scale performs a certain way. That's just a simple example, probably even overly simple, of how, number one, we ensure the resources and we also identify, hey, this is a critical activity. So if for some reason somebody decides to bypass the calibration, well, we're going to have a lot of errors going out the door when we send these scales out. Send out a shipment of scales. Hey, did you do the calibration? Oh, I forgot, or something like that. If you take the free tour, and of course, I wouldn't recommend that you do it now with everything that's going on, but someday, if you haven't taken the free tour at Harley Davidson, I would recommend that you do that. And when they show you around, you cannot walk 5 feet without seeing another flow chart. They have them everywhere. Okay. And again, it's to ensure quality in the process. What they don't want is people just, quote, rolling their own and saying, well, I feel like doing it this way today. Because when people are changing the process, it's that old phrase, you want a tried and true process. And so every motorcycle that rolls out the door, Harley Davidson wants to say it has gone through our tried and true process. If they've got some dude in there just rolling his own, making a motorcycle differently one day to the next, they can't ensure that quality. Okay. So simple example on a flow chart. Next thing we'll talk about is the checklist. All right. And a checklist, it's kind of like when you go to the grocery store. My wife actually, and she kind of gets on me for this. She's the one that goes to the grocery store these days because I'm kind of COVID scared that I'm going to get sick if I go. You're probably thinking, well, why do you let her go? That's because she does all the sanitary things. Anyway, I digress. The point is that when she doesn't make a grocery store checklist, inevitably she comes back and I'm like, hey, did you get those honeycombs? And she's like, I didn't write it down. All right. So, the checklist is kind of a common sense thing. I have some funny stuff up here. I worked with an Air Force guy one time who really started getting on my nerves. And the reason he was getting on my nerves, his name was Cliff. He was a good guy, but he would check behind me all the time. He would ask me, "Hey, did you do something?" I'd be like, "Yeah." And then he would go ahead and check it anyway. And we were the same rank. So it really was kind of driving me crazy. And I called him on it one time. I said, "Cliff, you're kind of driving me nuts with this." And he goes, "Hey, in the Air Force, we have a saying, in God we trust, everyone else we check." And now I can understand it if you're flying one of these. This is a C-17 Globemaster. So that's why I bring this in. Aviators are notorious about having checklists, and it makes sense. And I've watched them. They will check everything that could possibly make that aircraft crash. And if something fails, they're not flying. That's the bottom line. Okay, so the checklist is designed to prevent failure before it happens. They're not just checking stuff just to, quote, check the block. They're checking stuff because in that context, somebody's life matters on it, which goes to the second bullet. It ensures the resourcing that is critical and decisive to operations. So not everything in an operation is decisive or critical. There's things that need to happen, okay? But that's kind of the difference between a checklist and a flow chart. So for example, let's say that we have in our previous example, this one right here, okay? We've got to check the calibration station before we begin. So our checklist might look something like this. Calibration station. And maybe there's a pre-test that we conduct before we begin production for the day. Okay, so we go to that machine, we run that little pre-test, it checks out, and we put a check mark right there. That's why it's called a checklist. But let's say there's 20 pieces in that flow chart. We're not going to have 20 boxes here because not all 20 are decisive and critical to the operation. When they're checking out that C-17 Globemaster, they're not checking every single thing about it. But like landing gear, there's probably a landing gear check that they do. Pretty doggone important when you got passengers back there. I mean, we want to be able to land. So they're going to do that check. And if this is like a no-go, meaning they have a red check here, we're not flying that day. I was a paratrooper for a long time, and I mean, there's a lot of times we did not fly because the aircraft was not ready to go. We would have jumps scratched and things like that. So checklist, while it is probably pretty common sense, what I want to reinforce is that on the checklist, we're, again, checking the things that are decisive and critical to the operation. Okay. And again, in a prior life, we used to test fire weapons, pretty important before we would do certain things. But there were other things, you know, we would check to make sure vehicles had fuel in them. It sounds like common sense, but you'd be surprised how many times we'd get ready to do an operation and we'd have a vehicle that wasn't full of fuel. It happens, but that's why you check it ahead of time so you're not in the middle of the operation and you run out of fuel. The same thing could be here. We could have machines that need to be oiled and lubricated, have ink in them, have materials in them, those kind of things before we begin production. We don't want to step off and have a plan to produce 5,000 shirts in a day and our machine runs out of oil and lubricant when we're 200 shirts into the day. Okay. Then we're going to have all this unplanned downtime. Our labor force is kind of standing there looking at us. All right. So checklist, while it seems very simple, it's another tool that we can have in place to ensure quality. Okay. The next one is a favorite of mine. And here in just a few minutes, I'm going to call on you to help me work through and devise a fishbone for a very good friend of mine. Okay. But first, let's talk about what a fishbone is. I really like the fishbone because it's kind of a checklist on steroids. All right. And we can use it in a number of different ways, really two big ways. So it helps us identify either problems that could happen, all right, with an operation, or things that we want to ensure go well. So we could use it proactively or reactively. And at the same time, it groups elements of success or failure, so that we can kind of focus specifically. So let's just talk about these. In TQM language, we have often referred to this as, we used to talk about the 4 M's, and then just like the 4 P's of marketing, some smart person came along and said, well, you know, there's a couple more M's. And so now we have the 6 M's. And they're not really the 6 M's because we finally upgraded it, but let's just go through it. All right, so let's talk about these ones that are obvious. So machines. We want to think about what could go wrong with any sort of machine-like thing that we have, all right? In our previous example, we talked about the aircraft. What could go wrong with that machine? Well, we could have engine failure, we could have landing gear failure, so on and so forth. We talk about method, okay? Have we reviewed our method of flying? Have we reviewed our flight plan? Have we reviewed the weather check? Have we reviewed those things? Materials usually have to do with inputs. So do we have fuel? Do we have the right type of fuel? Is all the gear lubricated? Those kind of things. And up here with measurement, this is a little bit harder for folks to wrap their arms around or head around. But how are we measuring quality? Have we calibrated everything? So with the aircraft example, have we checked out our altitude, our altimeter? When was the last time that has been checked? When is the last time any other devices in the aircraft have been calibrated so that we know when the altimeter tells us we're at whatever, 5,000 feet, that we're really at 5,000 feet? Let's say that we're producing boxes in our process, and part of producing boxes is we need to weigh them. Well, when was the last time the scale's been calibrated? Because if we think the boxes are supposed to be 15 pounds, we don't want a scale that's 5 pounds off kind of thing. People. This is where one of those M changed. It used to be man, and then finally somebody woke up and said, "That kind of sounds kind of sexist, so let's call it people." Right on. So what's the status of our people? Have they had the proper training? Do we have any new people in the formation, on our crew, whatever? Those kind of things. Have they had sufficient rest? All right. And then this one we call Mother Nature. That's the 6th M. What is the nature of our environment? Okay. So have we moved into a new facility? Are we operating in the desert? Are we operating in a new environment? Those kind of things. Do we, I guess if we had a new machine, it would go over here. So this is kind of a way of categorizing. And of course, the same principles apply. What we don't want to do is create a haystack of things we have to check. We actually want to do quite the opposite. It's almost like taking all the things that could go wrong and putting them into a big sifter, and then shaking that up and thinking about, okay, there's a lot of things that could go wrong, but what are the things that matter the most? All right, that either are really going to contribute to our success or really going to contribute to our failure. Okay, and those are the things that we want to concentrate on. That's what I mean when I call it decisive. So what we're going to do is a tiny little group activity right now, and help out my friend at the same time. So my friend has asked me for some help to develop a fishbone so that he can inspect the Batmobile every time before he goes out on his nightly patrol. So what we're going to do is we're going to create a fishbone real quick using those elements of the fishbone, if you remember them. And if you don't, I will help you as well. So let's see here. So we have all these things. We have 6. We have those 6 categories. And what we want to do is have the Batmobile function the way it's supposed to. One of the things the Batmobile is supposed to do is go from 0 to 60 miles an hour in just under 2 seconds, which is like really, really fast. So Brenna, pick one. What is something in one of these categories that Batmobile or Batman should check? What's a category and what's a thing inside the category, do you think?
So the one for machine,
Yeah.
I think that was the first one. For that one, I feel like it's kind of important to check the brake system. Because
Okay.
if it can go that fast, I feel like brakes are very important.
Okay. Super. That's great. Marshall, what do you think? What's another one?
So we're looking to see if it goes 0 to 60 miles per hour in less than 2 seconds.
Yep.
So I guess for environment, making sure it's like not raining or anything like that, or the weather's good.
Okay. So if we have adverse weather, we want to know about it.
Yeah.
Okay. Makes sense to me. That's good. All right. Ashlyn, what do you think?
I think for man, I think that he needs to make sure he's good before he drives it. Batman needs to make sure he's good.
Okay. And just to be a little more specific, so when you say he's good, just pick one aspect of being good, you think, in your terms. How could he define good?
He's mentally ready.
Yeah. Of course, Batman's always mentally ready, but yeah, mentally ready. And one thing Batman does not get very much of is sleep. He is notoriously underrested, so he might not like that very much, but maybe Alfred can help him out. All right, cool. Let's see. Austin, what do you think? What's another one?
What were the other categories again?
So we have, let's see, we have measurement as a category.
You can make sure that the speedometer's like correct.
Yeah. I mean, if he wants to achieve this, he doesn't want some speedometer that is off. So he could have Alfred check that out. Okay, cool. Good. Casey, what do you think about one of these two? What could we put down here?
What were the?
So we have, let's see, we talked about man. We talked about measurement, Mother Nature, machine. I'm trying to think. Materials. So those are things, kind of inputs to the Batmobile.
So maybe like the armor that's around it, like any, like what that material is in case he crashes in any aspect going that fast.
I love that one. That is super. So check on the armor. If we've done any ballistic test on it lately. If the armor hasn't been checked for like 2 years, I'd be kind of, I wouldn't know about that. But that's a great one. Okay. And then Nick Salveson, what do you think about this last one? What might we put there?
For the methods, we could figure out like where we're going, where he wants to go.
Yeah. What's planned? So Batman goes on patrol every night. So what's his route plan? What kind of terrain? That's a great one. What kind of, is he going to be driving across rooftops? Is he going to be driving on the outskirts of Gotham? Is he going to go somewhere else? All right. So this is all good stuff. And all I wanted to do here was a couple things. One is just not blah, blah, blah for 45 minutes and you're like thinking about other stuff. But number two is get you into this stuff, get your hands dirty, and for you to think about a practical example on the fishbone. Okay. And again, in theory, if Batman checks these things or has Alfred check them before he goes out, he'll have a higher probability of ensuring quality towards this measurement of quality. Okay. And then maybe if he comes back, let's say he's out on his patrol, he sees the joker, he steps on the gas, he doesn't get that kind of response time. He's like, what the heck? He pulls the Batmobile back in and he tells Alfred, you need to check this thing out. Alfred could theoretically do this after the fact. He could say, well, I don't know. Did Batman have enough sleep before he went out? Was the speedometer working? So you see what I mean? So he could use this either before going out on patrol or afterwards towards ensuring that measurement of quality. Okay. And then just to beat a dead horse, here's another example of a fishbone diagram. This time it's towards ensuring good hamburgers. Okay. So when we go around the horn with machines, we could have storage and cooking equipment we might want to inspect. Methods, always with food, recipe is right up there. It's probably the number one example of a method with food. You know, are we cooking the right way? I know with chicken, my wife always gets on me. She's like, did you stick the thermometer in the chicken before you fed it to the kids? It's supposed to be 165 degrees, but it's all for a good reason, because if you don't, you're kind of inviting E. coli to come in and all that kind of bad stuff. Raw materials, of course, are the ingredients fresh? Have they expired? The environment, is it too hot? The measurements, my father is notorious for like not following the recipe. So he puts too much of something in there. He puts too little. And then personnel, mishandling is a bad thing in cooking. So here's another example of the fishbone diagram, this time with cooking. I really like the fishbone diagram because to me, it categorizes a bunch of different things. It also gives you priority, and it's a cool name on top of that, the fishbone. And you can use it before or after the fact. So to me, it's a lot more exciting than just the standard checklist. And I would bet money that if you start employing a fishbone today, you'll be a player like instantly, even more than you already are. Folks are like, whoa, where'd you get that thing? So exciting stuff. All right, moving right along, a scatter plot. Now, a scatter plot helps us identify the relationship between two variables. And we might see a positive relationship, meaning that as one increases, another one increases, or we might find a negative relationship, meaning that as one variable increases, the other one goes down. Excuse me. Or we just might find no relationship at all. And so when we think about quality, we can think about what things go together and then what things don't go together. So let's roll with a couple examples. Now, first, let me give some examples that aren't necessarily have to do with quality. They're still valued examples. They're more common examples. So we can talk about scatter plots outside of the topic of quality. So for example, and remember, this is my x-axis, this is my independent variable, this is my y-axis, my dependent variable. That's some Jackson Street language here. But let's suppose the x-axis is weather. And my y-axis is ice cream sales. So the whole idea here is that if I have this kind of trend, as the weather temperature increases, so maybe down here, this is like 40 degrees, and this is 90 degrees, probably my ice cream sales are going to go up as the weather goes up. Okay. And this kind of stuff is important to anybody, especially like marketing, operations, production. So we can anticipate that in the summer months, if we're working at Turkey Hill, our production schedule is gonna be more and more. In fact, it kind of makes you wonder on the topic of ice cream, if there's ice cream specialists, how much work do they get actually during the winter? Turkey Hill probably repurposes those people to produce other things, milk, other stuff like that. Okay. Or we might have, so this information right here is just valuable in terms of sales, for example. We might have a negative relationship. So let's say that our x-axis is still weather, but our y-axis this time is hot coffee. And we might have something that goes a little bit, I guess I should draw a scatter plot because that's the name of this. But we could draw kind of an imaginary line through there and say, hey, we have a downward trend. So in other words, as it gets hotter, the sales of coffee goes down. So these are examples. It's not that these don't have anything to do with quality, but I can think of even better examples that really get after quality. But still, scatter plot, it explores the relationship between two variables. Now, on a side note, it's not that the hot weather caused people to buy more ice cream. And this gets into correlation versus causation. The bottom line is that increasing weather temperatures are correlated with increasing sales of ice cream, but they don't necessarily cause these sales of ice cream. We'll never really know what causes the sale of ice cream. We just know that they kind of go hand in hand, which is another way of saying correlation. But the main thing is they have a positive relationship. As one goes up, the other one tends to go up. As one goes up here, the other one tends to go down. So if we continue to pull on that idea and think about quality, let's think about if we can identify two things that go together. So let's do this one first. And let's do an obvious one. And aviators are always talking about, even in the military, we always had to deal with crew rest. Has the crew gotten sufficient rest? So let's suppose that this x-axis is the number of errors in a process that people make, whether it's Batman, whether it's an aviator, anybody else. And let's say this is the number of hours of sleep that they get. Well, we would expect that as the amount of sleep goes up, so it's almost like we'd be going this way. So if they get a lot of sleep, we shouldn't get very many errors. Okay. I have found this in my current job. The less sleep I get, the more errors. So if the less sleep I get, if I'm like way down here, and there's been times, I know you don't care, I'm just kidding, but war stories where I've gotten like 4 hours sleep a night, and I still try to do stuff I got to do, and I make a ton of errors. And you guys are like, why isn't this posted? Or why did you misspell this? And I'm like, dude, because I'm soup sandwich. So the less sleep I get, the more errors I make, but maybe the more sleep I get, the less errors I make. So that would look something like this. So if I can identify, that's an obvious one, but if I can identify this, then maybe I could ensure more sleep, actually up there, and that would promote more quality performance. That's the connection there. Okay, so it's not just about sales. Now it's about ensuring quality. And, maybe I find something that, of course, I don't want this, but I find that if I do more of something, then it actually goes hand in hand with errors. And I can't think of something off the top of my head, but maybe I don't know what a good example here. More of something, the more errors that I make. Maybe the more times they get checked. I don't know. More times I yell at them. Those are
Maybe
obvious
more
ones.
times that you practice something.
So the more times I practice something, I would think it'd be like this.
Oh, that's true. Yeah.
Yeah. So practice, but that's a great example. Practice, maybe rehearsal. kind of things would go over here. Of course, I could over practice kind of thing. But you guys get the idea. And so I want to kind of identify things that are associated with quality, and maybe this should be quality. And then Brenna's example would work here. So practice hours. Like that. Okay, so the more time I spend practicing, the better performance I have. Maybe this is performance too. Okay, so you get the idea. What I want to do is I want to look for associations that either lead to quality or lead to instances where I'm going to compromise quality. And over here, I want to avoid those situations. Over here, I want to promote those situations. Okay, so those are examples of the scatter plot. And then we got a couple more. The control chart with our old friend Janet Jackson over there. So a control chart is where we identify if a process is in control or out of control. And based on if a process is out of control, it then provides the cue, the signal to us to investigate it. So this one, I want to quickly go to an example. So a simple example with this is where we are producing boxes. And let's say that we have our box line, and today is our first day of production, and then tomorrow is our next day, and so on and so forth. So this could be Monday, Tuesday, Wednesday, Thursday, Friday. This is could be week number 1, week number 2, week number 3, etc., whatever. And our boxes are supposed to be 15 pounds every time they come off. So that way the trucks are loaded properly and all those kind of things. Well, not every box is going to be perfectly at 15, although we would like it to be. And so maybe the average of the first day is a little bit less. The second day is a little bit more. The third day is a little bit less. But let's say we have something like this, where the fourth day is a lot more and the fifth day is a lot more. Well, in other courses, and I'm not going to ask you to in this course, we have mathematical ways of establishing what we call an upper control limit and a lower control limit. And Marshall, I don't know, you probably don't know this offhand, but I wonder, like Johnson Controls, if the name of the company comes from that kind of thinking, that it's associated with quality. But the whole idea here is that our upper limit is there's a point at which we'll accept boxes being a little bit heavier, but then there's a point at which we won't. Okay. And same thing for a box being light. Okay. And we could do this for tons of things. It doesn't have to just be with production. We could do this with athletic performance, such as like for Riley, like field goal percentage, rebounds, assists, all those kind of things. Any type of performance we probably can put on a control chart. Now up here with this right here, these points right here. So this variation right here is what we call normal variation. This is just going to happen. Not every box is going to be 15. Not every average is going to be 15. But, you know, this kind of variation is okay. It's normal. It's going to happen. Sometimes it's going to be a little bit heavier. Sometimes it's going to be a little bit lighter. But once we have this outside of our control limits, this is not normal. The technical term we have for this is called assignable variation. I'm not so concerned if you remember that for the exam and things like that. But, and the other reason I'm not so concerned is because assignable is not the best term. It doesn't really cue me to think about it. If I was king for a day, I would call this not normal or abnormal. Now, it doesn't mean it's necessarily bad or good. Let's say this was bench press. Okay. And Kevin out there, he takes the average of his bench press. And then all of a sudden we find that Kevin is like benching out of his mind. Well, it might kind of lead us to think, well, can Kevin sustain that bench press? Maybe Kevin's doing steroids or something crazy like that. But we could go back, and if we really had a problem with this, like these boxes are too heavy and they're causing us to short fill the trucks with product, and that's not a good thing because downstream customers aren't getting what they need, we could go back to our fishbone here and apply the 6 M's to see what is going on with this process that's compromising our control and therefore our quality. So that's where these things start to kind of go hand in hand, where we can use one tool and then pull out another tool to continue to pursue that quality and see what's compromising our quality. Okay. But the main purpose of the control chart is to establish those control limits so that when we measure performance, we can identify performance that's in control and then examine control. We can identify performance that's not in control. So it almost triggers us, it cues us to say, hey, you might want to check these out. Now, it doesn't mean that we're going to shut down the production process, that we're going to halt the production factory and all that kind of stuff. It may be that we have a new person on the job. It may be that we have a faulty scale. It may be that we're using the wrong materials to stuff the boxes or something like that, or we've got a new supplier, something like that. And we may be able to fix this pretty quickly. So it's not necessarily that we're going to stop production every time, but it's just like the indicator light on our dashboard. When that little engine light comes on, it's kind of like saying, hey, you might want to check this out. Okay. And that's what a control chart does. And then what else do we have? I thought we only had one more. We have two more. Pareto. I like Pareto. Pareto helps us identify the prominent reasons or causes of problems that are either problems or success. And Pareto is often used with complaints. So let's take a quick example. Let's say I run a hotel and I conduct a survey of everybody who stayed at the hotel for the last month. And I get some responses. And so I allow people to choose from, we'll just say 4 areas about what they didn't like about their stay. And so let's say I have continental breakfast. I hate continental breakfast at a hotel. I just hate them. So I'm going to pick on that. Let's say the swimming pool, something wrong with the swimming pool. Let's say room service. And let's say the cable, the channels that were available, or let's just say Wi-Fi. Okay, so the Pareto chart, and it just so happens that my highest amount of complaints were with the continental breakfast. And then my next highest were with the swimming pool. And my next were with this room service. And then I didn't get any on Wi-Fi at all. So that's what a Pareto chart is going to do, is it's going to put the leading category of either your sources of success or failure. In this case, we're doing sources of failure because it's complaints. It's going to put that leading one over here and then put highest to lowest. And the point of this that I really like is it forces you to make some decisions. And it kind of puts you, it forces you to put your money where your mouth is and get past an anecdote. So you might have one customer that you ran into that's like, hey, the Wi-Fi's spotty. But when you survey people, you find out that one customer was just about one customer. So if you chased after Wi-Fi and said, okay, we're going to solve the Wi-Fi problem, Well, the probability of you solving and appeasing the most amount of customers is very low. So it's kind of like chasing a unicorn. This is not the thing to chase. So let's say you do the survey, you get your staff and your team in there, and you put this in front of them and say, hey, folks, we got to go after the continental breakfast. We got to fix the continental breakfast. Now, what this survey doesn't show, or this diagram doesn't show, is where I would begin next, which is what don't people like about the continental breakfast? But maybe if you did the survey right, just like we do course evaluations, you had a write-in portion, and people wrote in and said, hey, the eggs look nasty, or there's only one waffle maker, so I can't get in there with my kids, and so I just don't go, or the coffee is cold, or whatever. Okay, but the point is, the Pareto chart tells me where I should expend my resources towards ensuring quality. And if I chase after something over here on this side, this is really not worth pursuing, because it's not going to put the biggest dent into the solution. We could also do this for success. So I could ask you, hey, what did you like most about this class? Okay. And you might say, whatever, A, B, C, and D. Well, let's just say this was D, and a few people liked this, but not many. Well, if I spent all my effort on, really making D be all the best it could be, I'm really not exploiting my success. But if folks said, hey, this A thing I really, really liked, well, I should turn up the volume on that. Okay. And really make that all that it can be. And then maybe not even worry about this right here, maybe take it out, or if leave it in, but not change it, but this is not going to put the biggest dent and make the biggest dent towards my contribution toward either my success or failure. It's going to be this stuff on this side of the diagram. So you can do this with just about anything. I really like the Pareto chart. You can get a lot of mileage out of it. As long as you can get somewhat accurate data, you just put it into a chart. And again, this over here is quantity. So this might be, 5 responses. This might be 30 responses. 30 people said they didn't like the continental breakfast. And then finally, the histogram is sort of like a Pareto. I don't necessarily put my leading category over here, and there might be a number of reasons why I don't do that. So, for example, I may get inspected. Let's say I have a process. Let's say I have a food process. I have a big restaurant process. And let's say that there's 24 areas in which I could get inspected, or that I do get inspected. You see this a lot on inspections. Accreditation for the college. When the college goes through accreditation, there's a number of things that are inspected. Probably the registrar gets inspected, every school gets inspected, so on and so forth. So let's say there's 24 areas, and this is kind of that. And let's say out of those 24 areas, 5 get an excellent rating. And then maybe, this is 5, and maybe 10 areas get satisfactory, or maybe, and then maybe I'm trying to make this to scale. I don't really like these numbers. Let's say 5 get satisfactory, and let's just say that 18 or 17 get satisfactory. Okay, so that would be 22, and then 2 get unsatisfactory. Of course, that 2 would be way down here. So that would be a reason that I might do a histogram versus a Pareto, because there is a hierarchy towards these categorical variables. And now I'm starting to get a little more technical than I want to. But I can't just put excellent over here, because then my chart wouldn't make any sense. Okay. So I have to keep these in the order that they are, because this one is greater than that one, and this one is greater than that one. Okay. But then the relative heights of these kind of show me, okay, 17 out of 24, whatever that percentage is, that's the most of my areas I did satisfactory in. So I have a lot of room for improvement. This right here, if I'm in the restaurant business, I have to fix. And probably pretty soon, in our current environment, this kind of diagram would be appropriate to social distancing implementation, where you can only allow a certain capacity in, and these types of things. And if you don't adhere to these measures, then you'll be shut down. I fully expect that kind of thing. So this kind of view for my team, if I have this kind of scoreboard, it kind of tells me, okay, how am I looking towards quality? Going back to the food business, I want to be more than satisfactory, because you know the deal. You've all been in those restaurants where the food is good, but you're kind of looking around and there might be a dead fly on a table, or you kind of notice somebody hasn't, looks somebody who's working there, kind of, you're like, ugh, and maybe you don't want to go back there. So in the food industry, you want to be more than just satisfactory. You want this thing kind of more skewed to probably look something more like this, like 20 of over here, and then the remainder or 4, and you have 0 over there. But the point is, on the histogram, you can't just make it like a Pareto. You have to keep some order down here. But the bottom line is, it does the same thing. It tells you where your quality is. And once you start drilling into this, so the first thing I would do if I had the chart with the blue is say, okay, what were these areas that we were unsatisfactory in? And we could go back to a fishbone, to try to solve that. What area with not a very good fishbone, but you get the idea. What in the 6 M's, how could we attack those 2 areas? Are they machine areas? Are they people areas? Are they Mother Nature? What's going on there? But we need to fix this 2 right away. And then once we fix that 2, how many of these areas of 17 could we move over here into the 5? Okay. But the bottom line is, just like all the other tools of quality, the histogram provides us a framework so that we're not just talking off the cuff. How did the inspection go? Oh, it went great. I mean, that's just not going to cut it. In the business world, that kind of vagueness, oh, it went great, that's not going to cut it. We need to have a lot more granularity on, well, the inspection went okay. We had 5 areas that were excellent. Really, the majority of our areas were satisfactory, which means we passed the inspection. We're not going to get shut down, but we could make a lot of improvement. And then we have 2 areas that we have to address, because the inspector's coming back next week. And if we don't have at least a satisfactory in those 2 areas, we're going to get shut down. So that kind of granularity, even though, hey, I don't like to hear that I have 2 areas that I'm unsatisfactory in, at least I know the scope of the problem that is in between me and achieving quality. Okay. And because if I don't, I'm incurring costs and I don't even know what it is. So those are our tools to quality. Hopefully, hope's not a plan, but hopefully I've given you some good examples. I'm sure you can think of many beyond the ones that we've discussed today. And I encourage you to use these tools as soon as you can out in your own lives, whether it's in your personal life, maybe in a job that you've got, maybe another course, whatever. The more you use them, even if you mess it up and use them incorrectly, that's the thing about using a tool. As long as it doesn't kill you, even using it incorrectly, you'll eventually learn how to use it correctly. It's kind of like baking. You can screw it up. As long as you don't get a E. coli, you'll live to see the next day, and you'll probably be a better cook the next day. What kind of questions do you have, big or small, on anything we've talked about today? I like that poster, Kyle.
You ever been at Disney World?
Have I ever been at Disney World? I have, long time ago.
Oh, nice. Do you think we're gonna come back to face to face in the fall? What do you think? What are your percentages?
What are my percentages? 51%.
We will 51.
No, that we won't.
Oh, you're 1-0 right now. You're 1 for 1 right now.
So my speaking non-attribution, I don't, guys, let me separate what I want to have happen to what I think is going to have happen. I'd pay money if we could come back in the fall. I'd pay money if we could come back right now. I have a big old party. I just am not, I'm not placing my bets on it happening. But I'm speaking as Matt Shatskin and not a York College employee. I just want to be clear on that. Vicus for boxing me into a corner.
Hey, no problem, man. No problem. I like your opinions. I like what you're thinking.
But on a sincere professional development note, and I always speak that way. I think that two things. You all have done an incredibly. I cannot say how incredible I think you all have done with this change. I know it's been difficult. It's been difficult on me. And I know it's probably something that none of us wanted to do, or very few of us wanted to do. At the same time, not to cause alarm, I do think that we're going to be living this way in the fall. I do think we should prepare for that. I don't want to. But for me personally, if I just said, we'll be back in the fall, I think I would be doing a big disservice to all of you and the future Warriors behind you. And I think I'm going to change a lot of the way that I teach. I still haven't figured this thing out. I won't even lay claim to say that I have. I thought I was starting to figure it out in the classroom, but this is kind of throwing a big monkey wrench in it. But anyway, so 51%, I don't think we'll be back. Actually, I think higher than that. But again, I say that as me, not a York College. I'm not speaking for York College. So don't run out and say, Dr. Shatskin said X, Y, Z. Because unless you want me to get fired, and then,
No, I'll keep it in-house.
Go ahead and rock on with that.
No, I'll keep
Ashland,
it's between us. It's just between us.
What else? Other questions, big or small? It's on your mind. What has to do this or not? So what you might want to do is think about, and on the quiz, I'll give you some reps on, when would you use which tool kind of thing. What tool would be appropriate for what kind of situation, that kind of thing. I just want to be clear, the chapter has some math in it, probably. I'm not concerned about math for you all. I'm not going to ask you to do data computations and things like that. Not going to get that specific, but I do want you to know generally what we've gone over today. And if you're interested, again, in this material more than what we talked about, then let's talk. Let's explore that interest, big or small, that kind of thing. If you're interested, I'm interested, for sure. With that, we'll close for today. I'll hang on the call in case there's any alibi questions, folks that want to hang out. Otherwise, again, we will not have Zoom on Monday. The next time we meet on a Zoom will be this time next week. We will have a quiz on Monday. It'll appear. I'll give you guidance on that. Watch for it. And if I don't talk to you, have a great weekend.
Thank you, sir. See you later.
Take care.
Thank you.